Pre-calculus 5.4 day 2 notes. So we're going to have some proofs where we're going to be using these sum and difference formulas from sine, cosine, tangent. And we're just given an identity like before. So we're going to make one side look like the other. But it did give directions here to use a difference formula, so you need to use a difference formula. And so on the left-hand side, you see tangent of x minus pi, so we need to remember that tangent of, say, a minus b is tangent a, and remember the sign on the top is the same for tangent. And then it starts in the denominator with a 1, and then you have the opposite sign from the numerator, so it's addition, and it's the product of the two. So we're going to be using that, but we, instead of a and b, we have x and pi, so we have tangent x, tangent x minus tangent pi, all over, it starts with a 1, it's the opposite sign, and then it's tangent x, tangent pi. And we're showing that this is going to be tangent, so put that equal sign, and we're going to keep on simplifying on the left-hand side. Well, for tangent of x, we don't have a value. That's okay. But we do for pi. And for pi, we're at -1, 0 on the unit circle. And tangent is your y over your x, so it's your 0 over -1. So tangent of pi is 0. So in here, we're going to show that substitution specifically. Make sure you show that you're substituting in that 0. For tangent of pi, so I can see that you knew the tangent of pi was 0. If you don't do that substitution, you won't be getting credit. Then you can simplify in the numerator. You have a tangent of x. And in the denominator, this might be a little clearer if you put parentheses on the tangent of x, and that you're multiplying that times 0, so that 0 and that simplifies to just tangent of x over 1. So we have tangent of x, and ta-da, that equals tangent of x. So you're going to have identity start by copying the original down and then working from there. Now, we can also use these sum and difference formulas to rewrite these other expressions where n is an integer, involving only sine or only cosine. So deriving this reduction formula, we are going to take this sine of 5 pi minus theta, and now we are going to be using these sum and difference formulas, but for sine. And if you remember, sine of a minus b, for sine, you start sine a and you use cosine b, and remember how the signs are the same, so if it's subtraction here. And then you start with the cosine. You keep the angle in the same order, so it goes AB and then AB, but you switch the two trig functions, and that's how I want you to do it. So simplify this expression. You write the expression, and we're just going to use this difference formula. And so we have sine of that first angle, cosine of the second. We're just going to make it theta. And we use the same sign, so since it's subtraction, it's minus. Switch the trig up, so do cosine, but keep the angle, the 5 pi and the theta in the same order. Now simplify what we can simplify. So you need to think, okay, sine of 5 pi, well, 5 pi is 2 pi plus 2 pi plus pi. So you are starting here and you are rotating around once. Oops, not what I wanted. You're rotating around once, twice you're to 4 pi, and then another half turn you're to here. So on the unit circle, you would be at -1, 0, and sine is y over your hypotenuse, which is 0 over 1, which sine of pi is 0. Or think about it graphically. Sine looks like this, and when it hits 0 again, you've gone 2 key increments, you're at pi. So multiple ways of thinking about that. All of that to say, sine of 5 pi is 0. And I need to see that substitution. I need to see this line with the written out and this line with the detailed substitution. Without it, you don't get credit on that. Oops, I just did cosine. So anyways, we also need to do cosine of 5 pi. Well, sine of 5 pi, sorry about that. So for the sine, we're using y over r. For cosine, it's x over r. So that's the -1, and the radius on the unit circle is always 1, and cosine is -1. Here was sine curve. If we thought about the cosine curve, when you're at pi, 2 key increments in, you're at -1. Just multiple ways of thinking about this. See which one works better for you, or be flexible and think about it different ways. Anyway, so that becomes 0 plus sine theta, and this whole thing simplifies to sine theta. So show details in that, and there you have it. So one more example here. Now this looks complex, but just think of it as 2 problems, just like what we just did. So treat the cosine x plus pi halves, just kind of don't, take it. We're going to do that as a problems in a sense, and then we're going to do the other cosine x minus 3 pi halves as its own problem and see how it works out to simplify, and it should, then we're going to simplify to something that we can solve because it says find all solutions. So evidently it simplifies to something we're going to solve. Now for cosine, for the addition, for cosine, you use the same trig function. It's cosine, but instead of having the same sign, they are opposite. So if it's addition, it's subtraction here. Then we change up the trig function, keep the angles in the same order, AB, AB. And so if it's subtraction, watch the get the patterns done so you don't have to be completely dependent on looking these up. Cosine, cosine, and since it's subtraction, it's opposite here, it's addition for cosine. Keep the angles in the same order, and then we're going to substitute. So we're going to start with this cosine of x plus pi halves. So it's cosine of the first angle, cosine of the second angle. Since it's addition, we do the opposite, we subtract. And then it's sine of the first angle, sine of the second angle. And so this right here is just this expression right there. Then plus, and I'll just change colors, why not? So for this one, it's subtraction. It's going to be cosine of the first angle, cosine of the second angle. Then addition, and then sine of the first angle, sine of the second angle, and I want it in that order. And this is an equation, so you need the equals 1. Now you need to evaluate. So we're going to be looking at, for this first one, we're at pi halves, 0, 1. And so the sine of pi halves is your y over your radius. It's going to be 1. Your cosine of pi halves is going to be your x over it, so it's going to be 0. And I kind of wish I would have put that a little someplace else, so oops. I've got to do this a little different. Sorry. I'm just trying to get that out of there, so I lost some of it. But anyways, the whole idea, you should be able to use the unit circle. We have cosine of x, and we showed at pi halves that cosine is 0, so show that substitution specifically. And then at sine of pi halves, you're at 1. Again, you can also think about their graphs. Now, we're going to move to the next one. And for 3 pi halves, I'll put it up over here. So 3 pi halves were here, which is 0, -1. So sine of 3 pi halves is your y over r, or -1 over 1, so -1. Your cosine of 3 pi halves is x over r, or 0 over 1, so cosine of 3 pi halves is 0. So cosine of x and cosine of 3 pi halves is 0, plus sine x, and sine of 3 pi halves was the negative 1. And so this is cosine of x times 0. This is cosine of x times 0. This product is 0. And sine of x times 1 is just sine of x. And then this product is just 0. And then sine of x times a minus 1 is a minus sine of x. So we have a minus 2 sine x. They're like terms. Solve for sine of x. And now we have to think on the unit circle, where do we see that the y-coordinate is negative 1/2? And we don't have infinite solutions. We just want them between 0 and 2 pi. So that's helpful to know, have your unit circle in front, or just know, because that's a lot faster, that those are going to be quadrants 3 and 4, because sine's negative there. And you're going to have x is 7 pi 6, or x is 11 pi 6. Those are the two angles where we have the y-coordinate, negative 1/2, on the unit circle. And so what angles correspond with those? 7 pi 6 and 11 pi 6. There you have it.